Okay, this time around this is another one. This is physics. So this is the question that you sent me. So I put it onto a slide. Yeah. So B part 1, they say explain what is meant by resistance. Okay. So this is the definition question with a twist. Okay. So with that, you need to know that resistance of a material is defined as the ratio of the potential difference across the material and the current flowing through it. So this is the equation, the formula. Okay, so then instead of looking at 5 ohms, we look at 1 ohm first. So 1 ohm is the resistance when a current of 1 ampere flows when a potential difference of 1 volt is maintained. So if you look at this, this is 1 volt is maintained, current of 1 ampere flows through, and then the resistance is 1 ohm. So this is when it's 1 ohm. So now your question, right, they ask for the definition for the meaning of 5 ohm. So back to that, it's 1. The key is 1 has been changed to 5. Then the current of 1 ampere flows through. This one may change, and the potential difference of 1 volt is maintained. So if I were to have 5 ohms here, then that would mean that I would have to have 5 volts that is being maintained when the current is 1 ampere. So you will need to reword whatever I said into a definition. So I say that 5 ohms is the resistance of a material through which a current of 1 ampere it flows when a potential difference of 5 volt is maintained. Okay. Then there is this second part. So the second part down here, we have the same drawing. Okay, we have the same circuit diagram down here, and then they say this is a 5 volts battery. So since it's a 5 volt battery, then that means potential difference or EMF is given. So so we don't have to do too much work. So I'll write down. Okay, so because the question, right, has charge, it has work done, it has uh time, etc. So then I would need to, in my head, pull out all the formulas that has charge and then probably work done. So then I pull out one, which is Q equals to IT, that means charge equals to current times time. Then we have another one, which is EMF equals to work done over charge. So then you have to figure out whether these two formula is enough or there is another third one. So over here, 1 minute here, then if we want to use this, that means I have to change it to seconds, so 60. Then you have Q, which is 60 coulombs, and then we do not know the current over here. The thing is, you have to think about it. Do you need current? Probably not, right? The question did not ask us for current. So then let's look at this formula. So we have EMF down here, we know that it is 5 volts. Then the work done is, I don't know, and that's what we want to find. And then charge is 60. So just with this formula alone, we can simply just do W equals to EMF times charge. That means it's 5 volts times 60 coulomb. 30 joules. Isn't it enough already? Then in that case, right, this is just a piece of information that is there to serve to confuse.